Well, so finding the equations of lines given certain information is exactly the same process that we did with our parabolas or hyperbolas, truncus. Doesn't matter what graph is. We look for the general form of the graph, substitute values in, invariably find a couple of simultaneous equations and try to solve. Now, if we have an exponential graph, typically we'll go e to the x plus b. So there's my translation left and right, dilation and movement up and down. Now, whether I use base E, base 2, in reality, you'd be given a general form to work with, okay? The same for my log function, okay? So there's my dilation there, translation there, and movement up and down. So that general form covers everything that we would like to work with. And as it says here, whether we use a log base 10 or a 2 to the power, it doesn't really matter. Whatever information we're given in the question, well, that's information we apply. So the equation on the graph shown here, find the values of A and B correct to two decimal places and hence find the equation of the function. So we've got 2 points. I've got 2 unknowns and 2 points. So let's substitute the points in. So I've got the point 0, 2. So x is 0, y is 2. So I get 2 is equal to a e to the 0 plus b. And point 2 gives me, what's that? It's negative 2.440. So I get 0 is equal to a e to the negative 2.44 plus b. So what are my two equations going to give me? I get e to the 0 is 1. So I get 2 is equal to a plus b. And I've got, if you like, 0 is equal to e to the negative 2.44 a plus b. So two equations, two unknowns. So if we use our CAS, working to two decimal places, so let's solve that on my calculator, and we get using our CAS a couple of solutions. There we get what's that? A equal to 2.19 and B equal to negative 0.19. So that process should be so similar to something that we've done previously, boys. So if we we'll continue that with the next example. What do we end up with? Again, we've got a couple of points. We've got a log rule here. So let's use the first point here, the point 0.5. So 5 is equal to a times natural log of 0 plus b plus capital B. And we've also got, what's our other point going to give us? We've got the point 2, 0. So 0 is equal to a natural log of 2 plus b plus capital B. So we've used the 2 points. We've got 3 unknowns there though, so we need to use three bits of information. The third piece of information is this one here, isn't it? The asymptote's been shifted to the left 1 unit. So that means that b there has to be plus 1, doesn't it? So let's, I guess, make a little change to the equations that we've written. Instead of having plus b in here, let's go back to a plus 1. Yeah? So now I can see that 5 is equal to a natural log of 1 plus b. Natural log of 1 is 0. Therefore, b is equal to 5. So if b is equal to 5, I get, what do I get? I get a natural log of 3 equals negative b, which is negative 5. So let's just undo that statement and put negative 5. If I divide by natural log 3, we get negative 5 over natural log 3 is equal to my a value. All right, so there's some exact values we can use. So we can say that y is equal to negative 5 on natural log 3 times natural log of x plus 1 plus 5. All right, so does that kind of make sense? I guess my graph's been flipped upside down, so a negative sign out the front seems reasonable. that's been moved 1 unit across. And if the graph has been moved upside down, that plus 5 sort of explains why our intercept is up there at 0.5. All right, so again, very similar process. Put in the unknowns, use the coordinates that you've been given, and then solve either simultaneously or using a bit of algebra. Have a go with 5F.